Okay, let's go with number 4C. I don't know if you can see it here, 4C. And it would be, the 4C would be, it's interesting, that's why I pick it up. Because here you only have one element, one molecule. It's bromine, and the bromine is being oxidized and at the same time is being reduced. So, as I said, you cannot have two that are oxidized. The one has to be oxidized, the other has to be reduced. But you can have one that it's oxidized and the other one, and the same one can be reduced. What is most important about redox is that you understand that the electrons are being transferred. So there needs to be a reduction if there's an oxidation. Hmm, sorry. Mm, okay. So we got here, bromine here is 0, but part of the bromine went to this and this. This is -1, okay? So here goes from 0 to -1, and the other part of the bromine goes to x plus x plus -2 multiplied by 3 equals -1. X is x minus 6 equals to -1. X, 6 goes to the other side, -1. X equals +5. So here bromine 1 goes to, see, it's 2, 1, and 1. So one bromine goes to +5 and the other one from -1. So how do we write the half reaction? You can do it double. It is the same thing. You can do it double or single. What I mean by double is that you can put Br2 on both sides of one bromine. hmm Yeah, one of the bromines from 0 is going, not take the coefficient this time. Why? Because this one, if you take the coefficients, you can do it, but you already know that one bromine is going from 0 to bromine +5, and the other bromine is going from 0 to bromine -1. So one bromine is oxidized from 0 to +5. It's going to be oxidation number going up. Electrons are being lost. So one is oxidized, Leo. It depends on the condition of the reaction. That's why this happens. And it's a reducing agent. So the other bromine, the oxidation number goes down from 0 to -1, so it's gaining electron. So it's gonna be GER, it's gonna be reduced, and it's the oxidizing agent of the other bromine. Agent. Sorry for that. So we got here from +5, 0 to +5 is 5 electron and 1 bromine because it's 1, and the other one is 5. 0 to -1 is 1 electron, and we got 1 bromine, 1 for each one. How I said, even if you write 2 at the end, you're going to have double coefficients in the reaction. hmm So here, if it's losing electron, right, it's going to be 5. The 5 has to be here. And here is going to be 1 electron. So you need to multiply the second half reaction by 5. And it's going to be 1 bromine here, bromine plus 5 electrons to be able to cancel out the, is going to give you 5 electrons plus 5 bromine. This one you have to multiply the whole one, and this is a charge, so you need to keep it the -1 here. So it's gonna be, we got, you can add them, you're adding. So we got, if it's identical the atom, you can do that. 6 bromine. Now these ones are not different because one is the bromine that is plus 5, that it's on the molecule, on the compound, BrO3. And the other one is the here it is. You can see it, Br minus. So in front of this, we're going to put, because we're going to need 6 to make the whole transfer. And this, the one that it has that, it has a 5 here. This is the net redox. So now it's basic. And we have minus, here we have -1, the charges, -1 plus -5 -6. Hmm. I can. Okay. So we got the 6 here. Let me recopy that. And I didn't, I'm doing this because it's not going to fit the water or the OH. And here is the, so the charges are 1 by 1 -1. -5. On the right side is -6. What will we need on the left side if it's basic? 6 OH minus, because on this one there's no charge, so it would be 6 OH minus. Let's balance with water now. How much water do we need to add? So we don't have any other hydrogen, so we need to add 3H2O to give me 6 hydrogen. Oxygen, we have 6. Here we have 3 plus 3, 6. And it's balanced. Now let's go with this one. We got here, let me take it down to, hmm, what a disaster. 5C. On 5C, okay. 5C, again, let's determine it. This is easy because don't have a hard time. If you have the OH in all of them, the oxidation state in OH, the oxidation state, remember, of oxygen is -2, a hydrogen +1, and it gives me a total charge of -1. So this is -2 and +1. And this is the total charge would be -1. This is a hydroxide. But we have it in the 3. We know it's not going to vary the oxidation state, but we can cross multiply because remember, oxidation state in ionic compound are the same as charges. The same thing with lead. Plus, well, you have to be careful. Sorry. Before I start, when you have a total charge of 0, you can cross multiply. In this case, you can't because it's not, it means that it's combined with something else. So you can either do the OH or you can do each one. M- -2, the oxygen multiplied by 3, plus 1 multiplied by 3 equals to -1. So it's going to be x1. 1 is the charge of hydrogen multiplied by 3 hydrogen. -2 is the oxidation number, sorry, of oxygen multiplied by 3, and this is x equals to the total charge. So this is -6. This is 1 by 3 plus 3 equals to -1. X would be -3 equals to -1. X would be +2. So lead is +2 here. And here 0. And here, yes, there's no charge, so we can cross multiply. So iron is going from +2 to +3. And if you look up, the Pb is going from +2 to 0. So the iron oxidation number is going up, it's losing electron, so it's being Leo oxidized. I'm doing everything, and it's the oxidize reducing agent. I can do it directly, but I'm doing it because of you guys, so that way you practice and practice. Pb is going. Let's finish with the electron. We got only one iron in both sides, 1 and 1. The same with Pb. We don't have coefficient. So we got from +2 to +3 is 1 electron multiplied by 1 iron is 1 electron. If it's losing, it goes on the right. Now with Pb, it goes to +2, so the oxidation number is going down. Electrons should be going up. So it's the opposite. Gaining electron is being reduced, and it's the oxidizing agent. And where do they go? You got 2 electrons that are being gained, and you have only 1 Pb. So it's 2 electrons. So you're gaining 2 electrons here. So you multiply the half reaction of the iron, and this would be the oxidation half reaction. And then let's copy it again. 2Fe without the well, 2Fe plus 2Fe gives me 2Fe plus 2 electrons. It's a charge, but it doesn't matter because it's not by itself. So 2 electrons, the Pb stays the same, right? You don't put a coefficient, you don't need to multiply the reduction of Pb. See, just remember the PB is being reduced. So you represent in an equation the reduction. Yes, the process is reduction. The same with the first one is oxidation. So you eliminate the electrons and it's going to give you 2Fe plus PB equals 2Fe plus PB. Taking it down to the equation, in basic solution, is going to give you, we take the 2 only, PB is 1 and 2. So now let's look at the charge. You got -1 charges, -1 on the left and 0 on the right. So what do you have to add? Plus 1 OH minus. Okay. So now you got the charge balance. We got 1 and 1. So now what do we need to balance? The hydrogen. Now let's be careful here because we have a lot of hydrogen on this side. Let's just be careful. Let's balance it first and see where do we need to add the water and how much. So we got 4 hydrogen here. 2 by 2, 4. Plus, we multiply the subscript because we've got 3 hydronium there, is 7, right? On the right side, we got 6 plus 1, 7. You see why I put this example? We don't even need to add water. For what? We have balanced that. Let's double check the oxygen. It should be balanced too. 2 oxygen. If it's not balanced, then you got something wrong. Plus 1, plus 3 here, 2 by 2, 4, sorry. 4 oxygen, this is the oxygen, 4 oxygen here, 2 by 2, 4, plus 3 equals 7. And on the right side, we got 2 by 3, 6 plus 1, 7. So this equation is not going to need water to balance the oxygens and the hydrogens. Okay, so now let's do the last one. I think it's the last one. hmm And this is another good example. What I'm saying that the nitrogen is going to be oxidized and reduced at the same time. The nitrogen here on the left is going to be oxidized and reduced. Let's just double check the numbers here, the, the oxidation numbers here. So we got here, right? We got, and here is x plus minus 2 multiplied by 2 equals 0. So x minus 4 equals 0. X equal plus 4. Here, x, one is going to here. X plus minus 2 multiplied by 3 equals minus 1. X minus 6. I know it already. I know x equals to plus 5, but I have to do the steps. Here, x plus minus 2 multiplied by 2 equals 0. X equals plus 4. So as you see, one nitrogen changed from plus 4. I'm sorry, I said why. One should change. Yeah, this is a charge of minus 1. That's the nitrite. So this would be minus 1. And this would be plus 4 minus 1. So this is going to be, one nitrogen is going to from plus 4 to nitrogen plus 5. And the other nitrogen Okay, where do you get the 2? Well, you put the coefficient of 2, or you get half and half. But better do it like this, okay? Because then you have to put half of the electron. It's gonna be a mess. So I do recommend you to do it this way. It's easier, and what you do is when you add them here, you take the coefficient up here. You'll see. So another nitrogen. So basically, when you balance the electron, one is going to N5 and the other one is going to N plus 3. When you are gonna need two nitrogens here anyway. So when you balance it, you'll see we're gonna balance it and have two nitrogen. So one nitrogen oxidation number is going up, so it's losing electron. So it's neo oxidized, and the agent reducing agent. The other one, oxidation number is going down, and in electron, grr, I'm doing all this, and it's reduced. One is reduced, the other one is oxidizing, and it's the oxidizing agent. It's acting as an oxidizing agent, and it's acting as a reducing agent too. So now, let's look at the number of electrons. How many on the first one? The nitrogen is losing one electron. How many nitrogens do I have on the first half reaction? One. So it's one electron. The oxidation number on the second one is going from plus 4, mhm, plus 4 to plus 3. So how many electrons is gaining? One electron. How many nitrogens you have in that half reaction? That how many nitrogens is being reduced? One. So you got one electron. And by the way, by one nitrogen and by one nitrogen, you cannot divide one atom in half. When you balance equation, you can put the half, the fraction, but you need to multiply everything by 2 to eliminate it. So we got one electron here, and it's gonna be, you eliminate the electron. We're balancing the electron when you add them, so let's add them. This and this is the same, N4 and N4, so you can put a 2, right? 1 plus 1, 2. Here on the other side, you cannot add them because 1 is N5. That's why I'm writing now the oxidation number in this net redox, so that way you're not confused. Because one nitrogen on the right side, this one is the same for both, which is gonna be here on the NO2. Remember when I was explaining the nitrate, the AT, has a higher oxidation number than IT, and this is the nitrite, NO2. So one nitrogen is going to NO2, NO3, and the other one NO2. Is it the same? No. So you cannot add them on the right, but here yes, because both are the nitrogen in NO2 and both have the oxidation number of plus 4. So it's N and N. Now it's in basic solution. Again, we got here a negative. What if we add, balancing the charge? Charge here is 0, here is minus 1, and here is minus 1. So it's going to give you minus 1 on the right side, minus 2. So now, how much do you need to add and where? You have to add hydroxide. Let me review that. You need to add hydroxide, and if you're adding hydroxide, hydroxide is the negative because it's basic. So you got here OH minus. Where do you need to add them from to 0? Or to this side, to the left, because it's a negative charge what we adding. So if we want to get here minus 2, because this whole right side is minus 2, we need to add here 2 OH minus. So now we got minus 2 on the right side, minus 2. Now let's check the hydrogen. No, we need to add water on the right because we don't have anything on the right with a hydrogen. So if we have two hydrogen, one molecule of water should be enough. Let's check our oxygen. 2 plus 4, because we got 2 by 2, 4. 2 oxygens. Let's check oxygen. Hydrogen we know already is balanced. 2 hydrogen, 2 hydrogen. Oxygen. Oxygen we have 2 plus 2 by 2 because we got 2 NO2 and 2 oxygens in each molecule. So it's going to be 4. And on the right side we got 3 plus 2 plus 1 from the water. And it's balanced. So it would be 2OH minus plus. That's the answer. And I think that's it. I'm gonna do the solutions video and that's for now.